Hey, this is Math Minutes Pro with Dr. Harrison. Today we're going to talk about how to identify a linear function. And in particular, we're going to identify whether a given graph represents a function. We'll also explain if the graph does not represent a function and if the function is linear. And I'll take some time also towards the end to further describe the graph using some notation for its range and domain. So let's go ahead and get started. Let's talk about what a function is. So a technical definition of a function, we say we have a function when we're referring to a graph when there is a one-to-one relationship between x and y. What that means is for every x value in the graph, there is only one y value. And now, there are different ways that we can do that. You can examine the graph, but the strategy I want to use for determining if a graph is a function is something called the vertical line test. So I'm going to write that here, vertical line test. So we're going to apply this test, and what that means is here we have a graph, and this graph, this curved line, we call it a parabola, all right? And we're going to draw a vertical line, all right, a line that's perpendicular to this graph, and we'll see if that line hits the graph at one point. Now, if that vertical line hits the graph at exactly one point, then we can conclude that this is a function. So here's my vertical line. I'll just start from here. So I'm drawing a vertical line, and we notice that this vertical line hits the graph, this parabola, at exactly one point. And that is our proof. We conclude, first thing we can conclude is that yes, we have a function. This graph is a function. That means that for every x value, there's exactly one y value along at any point on this graph. Now, we also want to, it says here, explain if the graph represents a function or if the function is linear. Now, in order for the function to be linear, the graph has to be a straight line. We know it's not a straight line. So we're going to conclude that this is non-linear for now. Non-linear. And there's another name that we can call this graph, but I'm not getting into that right now. We'll just call it a nonlinear graph. All right? And let's see here. Now let's talk about this particular graph in terms of its domain and range. Now, the definition of domain means all x values, okay? So let me go ahead and put that somewhere. I'll put it maybe here at the bottom. We'll say that the domain means all x values. Okay? And we'll say, so that's referring to this x-axis. And we'll say that the range, represented as r, means what? You're right. All y values. Okay. So let's further describe this particular function or graph. Let's do that by describing its domain and range. All right? Now, examine, if you will, let's start with the domain. So we're looking at the, let's say we look here for the domain and we're looking along this graph. And we want to say all x values in this graph. All right, so I'm going to say all x values that are greater than or equal to, and what is the lowest x value on the graph? Well, if you look at this graph here, this seems like this arrow keeps going and going, and so eventually we can see that the x value stops here. We're a little less than, -1, but if it would keep going if we extend this part of the line. So we can say it's negative infinity. And then the same thing over here with the x values over here. It would keep going. Well, not negative infinity. We'll just say, well, you can say negative infinity, but let's just say that. And if you see over here, for the x values, it would keep going. That's positive infinity. So we write, is there such thing as negative infinity? Think about it, all right? We know that it would include all negative numbers over here and all positive numbers over here. So from negative infinity to positive infinity. That would be your domain. Now let's start with the range. All y values. First of all, set it up here. All y values greater than or equal to, what's the lowest point on this graph? That's -4. So we say -4. Right about here, that's the lowest point on the graph. And then what's the highest? All y values less than or equal to, right, infinity, because it keeps going, but it's positive infinity. All right, so we have successfully done what? Let's review. We used the vertical line test to determine whether this graph was a function. We draw a line, and we noticed that when that vertical line hit this graph at one point, we said, yes, it's a function. We also said it's nonlinear because it's a curved line. And then we further described this graph, this nonlinear function, and said that the x values are between negative infinity and positive infinity, and the range value, all y values, between -4 and positive infinity. All right, so let's see what we can do. I'll let you stare at that for a moment, and I have one more graph we're going to spend some time describing. All right. Okay, so let's now move to another graph. We'll go ahead and erase some information here. Okay, so here we have another graph. It's a circle, yes. And we're going to still start with identifying whether this graph represents a function or not. So yes, we can use the vertical line test. And if we draw a vertical line all the way down through the graph, ask ourselves, does this vertical line hit the graph at one point? No, it actually hits the graph at 2 points, here and here. Then what do we conclude? Well, we conclude that this is not a function. Not a function. It did not pass the vertical line test. If this vertical line had hit the graph at exactly 1 point, it would have been considered a function. So let's examine this a little closer. For this x value, which is -4, we have one y value here and another y value here. We have two y values for one x value, -4. And so that means it's not a function as well, without drawing the vertical line test. Remember, a function is a function when you have one x value corresponding with exactly one y value. In this case, we got one x value, but we got two y values. If I come here at -6, for -6, I have a y value here, which is +3, and I also have a y value here. All right, so not a function. Now, is the function linear? We know it's not linear. Why? Because we have a circle. So we'll say non-linear. Non-linear graph. Okay? Very good. Now, let's further describe this graph and describe it in terms of its domain and range. Okay? So, let's see here. Remember, all domain refers to all x values. Okay? So we're going to say x is greater than or equal to, examine the graph. What's the lowest point that appears on that graph? Referring to the x values. All right, if we say this is the center, well, let's look right here. This is the furthest x value on the graph. If that's 10 and that's -8, then that right there, the x value is -9. So all x values greater than or equal to -9, right? And then go across all x values have to be less than or equal to, that's 0, so that's 1, +1. All right? Looks pretty good. So the domain values are all x values greater than or equal to -9, but less than or equal to +1. Now, let's find the range values. All right, we're dealing with all y values. So let's put our y first, greater than or equal to. All y values that are greater than or equal to what's the lowest y value. If this is -6, that's -8, then that has to be -7. So all y values greater than or equal to -7, right? And all y values less than or equal to what's the highest y value on the graph. Looks like if that's 2 and 4, that's 3. So we'll say +3. So the range is all y values greater than or equal to -7, but less than or equal to +3. Nice way. A mathematical skill that's very important in life is to be able to describe something. And we use the mathematical world to practice describing graphs, because you're going to need to do that to describe something when you get out there in the real world. So you practice your skill of describing and representing and testing something in the mathematical world. So thank you for watching. If you found this video helpful, remember to like, comment, and subscribe. And don't forget to check out my Patreon page on my video description below. On my Patreon page, you can get access to exclusive math lessons, study tips, live Q&A, and more. See you next time.